Good afternoon, everyone. Thank you very much for being here in such a difficult time of the day. So I hope that you don't fall asleep. And hopefully at the end of this workshop, you will learn more about mobile auditing and more specifically this one for OWASP. Let me introduce myself. This is the Pokemon file. My name is Eduardo Sanchez. I am a teacher of IT. I teach at a high school in the south of Spain, and I'm sure that some of you know me from the community that we created down there, Hacks and Beers, and I created together with my colleague Miguel Angel. We also have set up an association where we have three parties: the law enforcement agencies, technology, IT lawyers, and as well as IT experts, computer science experts. From there, we found the need to have a meeting in Cordoba. We wanted to name it salmorejo.com, which is the name of a local soup that we have. It was not very successful, so therefore we decided to give the name that is on the screen, Kuturba. And thank you very much for those of you who attended our meeting this year. And as far as I know, you had a good time. Also, another meeting which I'm very fond of is the following on the screen. Here in Cordoba, at the level, we, the teaching centers, have decided to come together and to set up a security high school. Last edition was attended by 560 people. The capacity of the auditorium was 564. To me, it was really a pride to see all those students giving talks, and some of them will be participating in the competition organized this time in CyberCamp 2016, and also Hacking Solidario. We give talks with a view to gather food for the most in need. So we give talks, awareness raising talks, inspirational talks to standard users so that the users learn about how to add security to the mobile devices. But the ultimate objective of our Hacking Solidario is to end up helping out those that are most in need. So this is the structure of my presentation. I will be giving you, as a way of introduction, information about architecture, security model, the different type of apps that we find in the market. Also, we will take a look at the OWASP project. We will focus on what we do with it for our audits. It will help us see and discuss those areas that are more open or prone to that are more vulnerable. Then third part of my presentation is about information gathering, then static analysis and dynamic analysis. First of all, we just want to get as much information as possible, and then we want to take a look at functionalities, and then to relate that to possible vulnerabilities. And then when it comes to automated tools, not everything can be done manually. In this cases, automated tools help a lot, as long as you know what these tools are doing at an underlying basis. So Android architecture, we are all well aware of it. However, we have to be very careful as to the different sections and what we can do with it. In the first layer, we have the different versions of kernels and the vulnerabilities in each of the versions. So here we have the Dalby virtual machine and the change to ART architecture. I will tell you more about the differences here. And what is here at the most basic level? Well, the drivers the drivers, that's what actually help connect the device. We know that drivers may fail, and sometimes we may find some security failures that may end up disclosing or exposing information. Second layer, we do not only have virtual machines. I will tell you more about Sandbox and how applications work on Android, and also the libraries of SQL libraries and SQLite. And this one is cheaper in terms of processing cost. We will use it for SQL injections in our workshops, and then I will also take a look at well-known security failures, such as Medium web browser. And then virtual machines, that are the machines used by Android to run process, to run applications. And here we will see how they communicate between themselves, bearing in mind that independence of codes and instructions and other capabilities can actually be compromised. In terms of basic functions for mobile handling, we will talk about content providers. So everything we see on the interface is known as an activity. We will take a look at the possible failures of those activities, how we can bypass an application, and just because we did not did any security by design. And last, the apps. Here we have installed apps or instant messaging apps, you name it. How does Android architecture work? Well, this is an example. It works on virtual machine. I run 3 apps, and I've picked these 3 ones randomly. I'm sure that you like them. Imagine that these apps share data, or for instance the application Badu or Lobo. Imagine that they could obtain or gather information from Tinder app. What does Android do? Android generates as many virtual machines as apps you have as runtime. Do you have these 3 apps installed on your mobile phone? Please, hands up. So notice there is an independence here in terms of the run thread and memory, processing, and codes. So therefore, if some of these apps break or some of the virtual machine fails, the whole operating system would not be impacted. It will just have an impact on the actual app that has been broken, and that's it. So therefore, we have independence here at the level of data and at the level of the application files and runtime memory. I don't know whether you have lifted and command shell. I don't know whether you did a PS, that is to say, to show the processes. You may have noticed the large number of users that we have in the system. If I am user X, why do I have so many users? The thing is that Android generates a user per application. Therefore, the folder, when you have the program installed, when you have the database, when you have preferences of that app, can only be accessed by the user that has been created for that application. This is what brings about the independence that I mentioned before. Differences between Dalvik Virtual Machine and ART. After version 5, which is Lollipop, now this IRT substitutes DMV. Dalvik compiles every time that you execute, and ART creates a compilation file when you install the app. What does happen here? Well, the result is that apps take up more space, take up more memory on the device. What is the benefit? Better performance in terms of usability and speed. And compatibility, no problem. We may run bytecodes from the virtual machine. We may execute that in ART with no problem. And sandboxing, and how does it work? So there are two applications there, virtual one, machine one and machine two. Here we have two users, different IDs, 1234 and 9876. And here we see independence, meaning that those users cannot communicate with each other. If I have the contact app on my phone, how does that exchange information with the other app? Well, for that they use content providers. So for you to understand it, app A wants to share something with AB and then puts whatever wants to share in a common box, and then each application takes from that box whatever information needs. Where does the problem come from? Whenever we are not the only ones having access to that box, but any app in the system has access to that box. And that is due to a security breach coming from the design phase. If you want to play around with the device, here you see the route that you have to follow to find out about all the permissions, all the apps. Then this is the root system -etc -permission. And when you want to do an audit and you want to learn about the applications and the users, the permissions, everything is stored in that file. That file is one of the most important, together with others that we show you later on: group permit, app identifiers, and users identifiers. This is an introduction. And before I discuss with you the auditing. So we also need to be aware of binaries. Whenever we install an app, by default, the APK is stored in a file, and in that file we will have all the applications. We will also have a number of functionalities, and they are loaded in the system bin and system X bin. If we want to add new functionality to the operating system, for instance, a grep command, if we want to add that to Linux, we would have to install it in that location. Then the applications are installed in data, and then the backup of the app is stored in the data/APK. So if you need an APK and you cannot find it, however, if you have it installed in a mobile device and you don't find the version that you want to that you need, you will find it in that location, in data/APK. Whenever we do auditing, we focus on the latest version. What do I use to go to prior versions? In this case, there are two URLs: APK Pure and APK Downloader. For the first one, you will have historic data from the first to the last versions. And question now, how many of these apps do you think that from version 1 to version 7 have been capped? Do you think that the mere fact of installing version number 7 is leading to the capping of the 6 prior ones? So what happens here? If versions 1, 2, 3, 4, well, let us say the last one is the latest. If the prior versions have a security failure and they let me access the server, even if I limit that security failure, in version if I am in version number 7, but if I continue to allow access to the prior versions, the security failure is not resolved. The main problem here is that they are signed with the same certificates, security certificates. And when it comes to accessing the server, we find that access is open. And then I will show you an app for a very famous chain of gym, when the last version is asking you for the username and for a password so that we can take a look at the timetables. But in the first versions, you didn't need to enter the username and the password. Why the prior versions are allowing you to gain access to the server? You have to stop that. We have to stop that. And other files, well, I'm sure that you've seen them before on the internet. When you have an unblock button, when you have a PIN code, if your telephone is routed and if you have access to it, just go to the data/system, and there you delete the file that you want to delete, the file with that pattern. Here you will find some files that are important. This is an example of an Android app, which is just a packaged file with a .zip. We have Android manifest, which will be the heart of my application. This is the first thing that we will attack. Everything that the application does will be found at Android manifest. If I take application.apk and I rename it and I name it .cip, that will give me automatic access to a number of files. But some of those cannot be read, for instance, the Android manifest. And other files that we can see here, the class.depth, it is just the different classes of the app. This is a Java app, and this is the class of the app in the code of the Dalvik virtual machine. And then we also have resources. Here we have the resources, ARSP. Here the resources means audio or any multimedia files. And here also unzipped, we have images. I don't know whether you know that an app in Android, when it comes to developing it, if your terminal is horizontally or vertically placed, the code that is being run is completely different. So in the app, I'm going to say when you run, when you are horizontally, run this code string and vice versa. So we have different lines of codes, different code strings for different positions of the device, and then we also have different images for viewing, for different viewing modes. And well, after discussing architecture, we move on to the security model. It is based on 3 points. First of all, any action requires permits. Any action needs to have specific permits for it. If the app wants to use GPS, it requires specific permits. If it wants to access contacts, it also needs a specific permit. So the app cannot do anything whatsoever without these permits being awarded and approved by the user. Second, all the apps have to be signed. Here we may discuss whether this signature is done through a certified entity or if it's being us who have generated that signature. But anyway, all the apps that we download and to install should be signed. So therefore, if we download an app from Google Play, what we're going to do is to break the signature, and by the time we want to sign it again, we cannot sign it with the same certifying entity or through the same certifying entity that the manufacturer used. And third, every app that is installed on the device requires the creation of a user. 30 apps, 30 users. 50 apps, 50 users. Who breaks this security model? Well, users do. The problem is always us. And first point, All actions require permits. How many of us says next and next and accept every single permits of the app? Can you please raise your hand, those of you who do Facebook on your phone? And please raise your hand, those who do WhatsApp, Instagram, Twitter, etc., etc. 90% in this room will meet what I'm going to say. So we have the possibility to limit permissions or to close or disable permissions, permissions, because we have to be well aware of it, of the information that we are disclosing or that we are allowing to be accessed. And then when someone says, okay, I'll give you this app to hack the WPS of the router, but it is not available in Google Play, you may download it from here. What do? We install the app and we install it, and then we install it from an unknown source. It doesn't really matter whether it has any bugs in it or not. It may end up hacking something, cracking something, but despite all that, we end up installing it. So today we were traveling on the train, and one of my students had an app that was a whip, and then it was also emitting some sounds. And I say, why does the app wants to access your contacts, all the information that you have on your mobile phone? We have to be very careful about these apps and the permissions that are required. How many of you have rooted your phones? I would say the same thing. Rooting your phone is good as long as you know what you're doing and what you want it for, what you do it for. The moment an attacker has access to any of your devices and does that through the root user, we have more and more access to information. Therefore, it depends on you whether you want to root your phone or not. I always give the same advice. If you want to root your phone, do it because you know what you are doing, because you are aware of the processes and apps that will have access to some system functionalities, and do not root it just like, well, because I need this app which is really cool, I need it, and I'm being asked to root my phone. But if you do that, you may end up having a highly compromised mobile phone, allowing access to a great deal of information. Dual authentication factor, two-fold authentication. I don't know whether you are aware that in this case with Google Authenticator you can obtain the keys that are used for the two-fold authentication. So you go to a virtual machine and you can do it. Some default apps, for instance for mail, store your username and your password in plain text in your mobile. And what happens if I have a device where I use an email app that stores username, password in plain text, and then I have the Google Authenticator and have gained access through a Trojan or malware? What will it get? You will get access to the database, but I have the password of my username in plain text, and it will also have the access to the database with the keys for the second factor authentication. I don't know whether you heard that access to a system is not 100% sure unless it fulfills three requirements. Those being that to access that you need to say something that you know, you need to authenticate yourself with something that you know, something that you are, and something that you have. Something that you know, your password, something that you have, for instance, a card with keys, or any kind of hardware that I may introduce so that the password in it can encrypt it or decrypt it. And third factor, for it to be 100% sure, any biometric pattern, whether it is fingerprint or you name it. So these are the three requirements that you need to ensure that your system is 99% secure in terms of authentication. So you've seen the security model and how you can break it. You may agree with me that we users are the ones that uh, do the routing. We install other apps just to get at what we want to get. And now, applications that we can find here. First of all, we have web-based applications, which are these ones. Those where I have a user interface, and where that user interface will give me access to a web service, and where I will be getting access to the online database so that the application can operate. I will have little information on the device. Now we have native apps. Everything is embedded in the actual Android operating system. I have the database, preferential files, and it works independently from access to external server. So I'll tell you how easy it is to do SQL injections here. And then last one, we have a hybrid model. And here, hybrid applications. So part of the information is on the device and part of the information is on the server. The third one is the most common type of application. You know that most of the applications require you to have access to the internet, and that are always these are apps are always open to auditing. Let us stay in between the two and find out the information that we can access from there. So now, OWASP Mobile Top 10 Risk 2016. These are the top 10 risk or security failures for mobile devices. So the first one was SQL injection, and now it is maluse of platform, improper platform usage. So that means that the operating system is not properly used. That is to say, information is stored whenever it should not be stored. For instance, username and password in plain text. Also, information or is being accessed in an unsecure manner with no encryption. Then number two, we have insecure data storage, insecure communication, then apps that communicate with a server without going through SSL, and then apps that are storing information that it is not encrypted. When you download and install any app, the first time when you register, you enter your username and your password. That information is in your device and it's not being encrypted. And by the time the device will communicate with external servers and uses those credentials for that, that is not done in a secure manner. And then those of you doing audits or into auditing, so here OWASP offers you this list, which is the roadmap that you have to follow for each of these apps. This is a list of questions and things that you have to check in your audits. So these are a number of items that will facilitate your work and that will help you report to your customer. So there is also a guide available as a guide for the telling us the steps that we have to follow. Imagine that I want to audit Pokemon Go, and what should I do? All right, first of all, we are going to do information gathering. Who is the manufacturer? What are the applications offered and developed by that very same manufacturer? Often we do code reuse. If I have a graphic library, if I have a cryptography library, any kind of library for communication, I'm going to use it. I'm going to reuse it across my app. And well, we may go and say, I audited app A, but applications B and C from the same manufacturers, I did not audit them. What may happen here? If you take a quick look at those apps, you may find a security failure that may also compromise A. That is to say, the app A, which is the one that I'm auditing under request of my customer, and then obtaining information through interaction with my app. If we are going to strip or take apart Pokemon Go, what are we going to do? Well, let us see how it works. And after, well, I tried it, but I'm not very fit, so I decided to stop after some time. So, next step, very, very important, static analysis. So, we have found hard-coded, that is to say, keys in the source code. Do they think that we cannot access it? No matter how much we conceal the code, there will always be a source code, and there will always be a password that will be found by the attacker. The problem here is whether it is encrypted or not. What else? We are going to analyze permission. So this is a sworn statement for the app. They said this app does this and this and that and requires this and this and that permissions. And last, dynamic analysis, which is about functionality. We are going to try code injection. We will try to bypass the app. We are going to try that content provider. We are going to see whether only the server and the app access that content provider, or if we access it as well, whether we can send out information to it even if we are not the server. This is a summary of the steps that we will be taking. And now a couple of links about the information that I shared with you up until now. I guess that you will be getting this information, this presentation, but if you don't get it, just let me know and I will send it out to you.
What structure can we find within the applications, or where are data stored? One of the main items is failure at storing information. I'm about to develop an Android app. Where will I store data? Where can I find out as an auditor where the information is? So there's several options. First, shared preferences. What's this? So main problem is for us users that we are not very good at using resources. It's an improper use of technology. If we have a preference folder, what is it used for? What I save there, it should be there. There is information that should not be risky for the operating system. And yet there are users and passwords there, usernames and passwords there, but other information should be stored, such as setup, type of OS, size of the app, etc. Inside storage, I don't know if you know all different kinds of storage options within Android. We've got the user memory, the ones you can see if your phone is not rooted. And then we've got the inside memory, internal memory. Here we've got pictures, we've got downloads, and there's another one that it's called internal memory, but it is not. It is just an emulated folder from for the OS. When we go where we want to go, it's to the core, that it's the internal memory. It is the memory. There is one permission that is known as private mode. And that information is not accessible to anyone but the user. So we've got the user memory and we've got the phone's internal memory. If we've bought an Android device, we cannot have access to the internal memory. Only each single user to each application can have access. Tinder, Badoo, and the other app that we said before. Inside Tinder, the user that is produced will have access to the internal memory, to the folder, and that will be data, and app name, that is Tinder. This one is accessed only by Tinder user, no one else. The minute we root the phone, the root user has access to the whole OS and the internal memory. So private mode is very good, it's very nice, and that's what most apps do, and that's why they do not take care to encrypt the app. If it's only the user that will have access, there's no need to encrypt information, right? But that's not true, because the minute we root it, we will have access to information. If I have a password or an email account with a password, either I have the key from the Google Authenticator, the two-factor authenticator, because we say that a root user can take two of the three factors that I mentioned before, key and two-factor authentication. By the time I'm done, you might ask, where do we store data? That's a good question, because if we can have access to the internal memory and the shared preference files, what happens then? What about outside storage? This is used by the user. They all have access. How many in this room, hands up, how many of you use save on to the memory card? You've done it, right? You know what happens? The minute I store an app into the memory card, this thing that it's only the app user that will have access, that goes down. All applications have access and all users have access to the memory card. So if you ever take and transfer or copy or install an app into the memory card, it needs to be with that sensitive information. Never do that with your email account or your bank app, because if there's any kind of information which inside a database would be, breached, if there is some information leak or if it contains sensible information, any app can have access. So try and install only those that have no sensitive information, because there you see something that anyone can read. Everyone has access. And then, second to last place to store information. Where to keep data? That's where you need to keep data for Android apps, and that's SQLite database. When you store information in that very folder on the internal memory, as I said, it doesn't guarantee, it doesn't ensure that it will be secured and protected. Information needs to be encrypted at all times. My option, the best one, I would say, keep your data on the web server. As long as they have sensitive information. If I need to have access to given information, it has to be done remotely on the web server, and that's where security is to be. If I have username and password or some kind of token on a shared preference Android system, let's do so in a coded way. None of us log every single day into our email account on the cell phone, right? They need to get credentials somewhere. Where are those stored? Naturally not on the web server. It's not there. I need to have it on my local database on a preference file, but it needs to be encrypted nonetheless. So here we had quite a wide introduction, but we needed to know what the system, the structure, the parts to it were like, everything about security, to see how I can audit an application that it's Android. Different ways. We can get a real device or we can produce a virtual device. But it will always be through the Android debug bridge. This is just a bridge between my terminal and the device, the operating system, so my interface and the system. Usually, all apps use client-server communication. This is a bit weirder because client and server will be on my machine. The only thing on the device will be some daemons getting information and returning information. And on the machine where I have my prompt, I have client and server. The client sending information or instruction, and the server communicating with daemons that are running on devices. As it happens, when you start playing around with devices and also auditing, this ADB port is collapsed, and you need to get rid of the daemon. How is that? Those are the commands. This is build server command. But communication, I control it from my computer side before connecting. If I use a virtual device, just the same. The daemon works within my own machine at a given port. Check this out. There are some figures there. When we are using virtual devices, Android numbers them according to several ports. If I want to simulate, I don't know, phone calls saying that there is a malware, and through these SMS, I want to test it. This would be the ID, the number that it is needed to use different Android devices. So I have two virtual machines inside my computer on Android, right? Each of which will have a number. If I want to call from one to the other, send an SMS or call to test or any of my apps, what I need to dial are those numbers that are the ID numbers. So just note this in case it happens to you, if you need it. So again, taking apart Pokemon Go, and you see, we're talking about Android architecture. It seems a philosophy lesson. Let's move on to practice. We install it, and what's the first thing we see? This is a company. You see underneath Pokemon Go, this is the one that developed it. This is important. I'm going to set up an app, so first I need to know the app, the environment, if there is code reuse, and we need to understand how it works. Permissions that are privileges that are necessary. We will see that with Android Manifest later on. I don't know if it's happened to you, but there is this series of privileges or permissions, but when you're going to disable those inside, you find others hanging around, and you find it is weird. This is kind of a summary. And these privileges are reporting to each other. It's always the same identity, but identity for what? For the phone? Or my user? You've got MZ and email. Email is for the device, and MZ, me as a user. So this is my card. There is a code in it that authenticates with the telephone antenna for a phone call. Why would the app need to know who I am? To sell my data, for sure, but we should not allow or grant those privileges. If there is an identity problem, we don't know whether if they want to have access to MZ, email, or both. So we need to have manufacturer's information. I go into Google Play and I find these other apps by the same company, which, well, I'll try to find code similarities. So I'll reverse them. I get the source code for Pokemon and the same for these other two apps, and I will check the code and see what functions or what libraries are shared. Why? Well, maybe these three apps have been signed by the same security certificate. What if an app tried to gain access to a content providers, as we said before, content provider for Pokemon, that it is locked? Once spotted, so when the Pokemon app is spotted, we see it is signed by the same one that signed it to me, so access is granted, and we lose control. There is no development control there. A failure in any of the developers' app may give me access to Pokemon Go. As I said before, we only see versions that have been updated, and these are the latest. If I look around in websites where we get the history, such as Apica Pure, we will find that this producer himself, or themselves, had produced Super Mario Run. Why is it off Google Play? Because is there a breach? Is it not? So what can we find here? But probably right now, someone unaware of another manufacturer or other app, yes, I would go to this app, to this APK, and try to analyze its source code, because we will find code similarities for sure between this app and Pokemon Go that will hint to me what a library has patched or the manufacturer has patched and where I can break in. There's something good about it. We could try and see every version available, first to last, on APK Pure, as I said before. How do we get extra info? So that's what's so fun about it. We are gonna start playing around with the game. So let's start hunting Pokemon, and once we start hunting, we'll try and get information that it's at a user level, and you can all do it. I set up this app, or one like this, to analyze and look into the connections that happen as I am hunting, and I get so many IP addresses for the app. All those are to be tested. So, as it is, we see port 80, a couple of IP addresses over there, 443, 2 bar. So part of the communication we see is using SSL 443 protocols. Another one goes through the port 80. We get info, and we've got an entry point to move on with our audit. As I said, we will have a man in the middle, so stay in between the game and the internet connection, trying to see what information I can get. Once we've passed this information gathering stage, I can hunt 500 Pokemons, so many Pokemon meetings that I can be to, and that way I need to have valid information. So I cannot spend so many hours just to get 4 IP addresses. It will take us just a few minutes. So static analysis now. What do I get there? Basic tools we'll be using. First, APK tool. Any reversing tool you might think of to get source code out of an Android app is running on APK tool. It all has APK tool running underneath. You see, there is APK tool for compile and the app name. That's what you find. Those are the 3 commands you find. It takes a bit until it gets some source code that is .hard. Well, we'll see the classes later on. And what I want to get is Java. I will get source code information transferred into Dalvik to get the Android manifest and the certificates for the signature, which I can get to know who it belongs to and whether they are valid. But then, code is bitcode, right? For Dalvik virtual machine, I want the Java code next. What do? Same thing. We get vex2jar, another app that runs on the frameworks you find on the internet. I get a .jar, as you see there, which is just a packing app of Java files. This pack I will open with a different app, and what I see is the source code. Source code for the app, you can see on screen. You see 47.1 version that has been downloaded over there. Another thing that is done, I download the first version from when Pokemon was developed, and I get the last one. And when reversing, I compare the manifest files, so that would be Android manifest files, to see if said information has changed. And maybe a function has been added, something else has been patched. Initially, with the manifest file, we can spot a few vulnerabilities. Just in a minute, let me show you how this process works. It takes just little time. I don't know, it's 2 minutes, 3 minutes. That's all it takes based on the machine and the package. And once we've got all the files, we just need to transfer information we obtained. This is the one, .x. This is for Dalvik virtual machine. And now we want the Java code. Once we get it, I get the .hard, and then I can go through it. Go through the OS files. What you see there is just Android manifest. First thing we see, next slide, is try and get first activity, first screen for our program. That's the main. And then we look for launcher. It's down there. Once we have the launcher, we'll get the name for the main activity. And now we just need to hierarchically browse along the source code, looking for Unity player activity, and we find that code that is the one that is run first. When we have the app, that's what we get. So first screen, we got logins, what other processes, services are being called, as long as it's on the Android manifest after reversing it. So we got the source code, and I wonder, where do I go? See, this is a forest of information. I go to the manifest file, I find the launcher, which is just the main screen, and then I keep pulling the thread. Since this is hierarchical, I just need to follow the pathway. There is some other apps where we directly upload it. This is APK Inspector. We upload the app and it runs it all, decompiling .dex into jar and jar change. And there I get it all. You see the launcher there, right? This is the first thing. And for the activity, we find Android name. That's the app name. That's .activation. Here, this would be an activity inside the main packet. Do we have a pointer? What's the main activity? This is the name. This is the launcher. See what it is? This is the first thing to be uploaded. And this is the activity name. .activation, that is just was package. That is the name .dms. And inside is the window that I've shown you. Other apps, other resources that can be used for this, such as, you say, Eduardo, I have no access to my computer. I need to check the source code for an app that I got. What do I do next? There are online tools such as this one. This is APK compile. This is compiled Java, right? I should like to recommend this blog within the Android cybersecurity community for Android and iOS. Indian people are great at auditing. They are here today. This is Mobile Security Wiki. It's done by an Indian fellow where you have online resources both for Android and iOS or Windows Phone. Believe it or not, there are devices running on Windows Phone. Who's an owner of Windows Phone? No one? Are you ashamed or raising your hand? No. It is the security backup device, right? In case it breaks, your first one breaks down. So, upload APK, analyze, and the whole process. If you're out in the street and you've got a student and says, Eduardo, I need to know this information. Well, you add it, run it from your phone APK, and that's your info. So understand it as you will. Take it as you will. Manifest file. This is our app. We've been hunting Pokemon. I get the source code, and what next? How do I start it? This is the manifest file. How do we look into it? What do we find there? First, package name. That's what we will have, and we will find inside the operating system here. Niantic Go. We can corroborate the privileges granted before. So there are many privileges, permissions there. You need to find them on the internet because some of them are quite unknown. Bluetooth admin, and many others. Down there you could find many more permissions all around this source code. So first activity, main activity launcher. Go there. And this is the first one I get. And I get the name, Android name. There it is. .player, blah, blah, blah. So, what you get there is just a root, a pathway. As part of the packing of Java source code, Go Unity 3D player, that's the pathway to reach the source code for the main screen. And from there, we start pulling the thread. Next, let's find exporter. So services that are exported, content providers that are exported. So some information which means that it is open to the public, open to all other apps. If we find export true, it means that I can walk and handle the app. The report will not be empty. I will find out some vulnerabilities. Something else up there. For debugging, there's some information used within the source code that we do not remove. I include myself here. We develop, we leave some debugging info in, which we do not remove. We just state whether it is debuggable or not, which means that on this OS lock, these alarms are not activated. I can look for it, I can reverse it, and I can find information or messages written on the log, and if I have not removed it, this is causing an information leak. If it were true, the minute I used the app on the system log, you will find some information that an attacker could use. For an auditor that uses that profile, the attacker profile, they will find it useful. Let's get started. So what do we do first? What do we look for inside the code? Keywords, passwords left behind by a user because they've been hard-coded. They are into the source code. This is an app. Okay, we will find some security breaches that are common to apps. Going into Pokemon Go, and there's millions of downloads, so it's difficult. Just we'll see what the security failures can be like and what we can find. So go and picture. This is an app where a password is requested, but we work on reversing it a bit, and we find both the password or APK or what we see there. API keys. So by pulling the thread, I find a screen where a key or a password is requested. I go to the source code, to that fragment of code, and I'm trying to find the comparison, which is up there. Function is called access, so I will have access as long as the code equals vendor secret key. So what can I do? I can bypass this screen. This is an activity I bypassed because that source code is not ciphered. It hasn't used enough mechanisms to do it. But then the smart one comes along. Now it all comes along and says, yes, I do encrypt it all. I have a stream password and a hash as well, right? So that what do we all do? Copy, paste it. Password is one, and we find it on the internet. The word is password. We can always have a local password at hack. I get the hash. I add dictionaries till it is found. I've got all the time in the world because it's on Google Play and millions of users have it. And what if I get lucky? How do we do it? Just let me show you. First, let me tell you, I've already reversed the app. This is Android Labs. I've reversed it. And what I do, it is just having access to that code. Let me see if I can stop it. Once I've reversed it, there is this folder that is Smollett code, and I have a recursive search, and you see what I've typed. I will look for a password, web for injections, because it's the frontal asterisk. So I can look for some keywords inside the source code on that Smollett code to see, is there a chain saying reset password, and what do I need to get? Where do I need to access to get there? Well, simple enough. To gain access here, the pathway would be simple. COM-IST, secure login, main activity, .smollett. So main activity within this pathway, that's what I get. Same here. Is the video over? No. Let's play it again since I've stopped it. Sorry about that. So, search, go into Smollett. This is something I've reversed already. And the package is in the CyberCamp secure login folder. Once I do this, so what about the password sender? Well, I go to the source code and follow the pathway. This is quite simple because it's been packed and there's not much code. Oh, thank you. It is so simple as doing this. I now paste the search onto the browser and the password is there. If not, just run a password attack. You brute force it, locally or online. Same with Pokemon Go. I've reversed it already. And what I do is go into the Smollett code and try and find some kind of password. This is recursively done for every single folder. And as it happens, I will find the word password with different parameters. So this is a function that is credentials, and that's the whole route, right? That is followed with Google Android GMS, and that's what I do. I go to Pokemon Go with Google Android GMS. I just follow it within the source code all the way there. Like this, I got the access route. Is it concealed? I don't care. Because on the Smollett code, I'll get the strings, and just as they are. See the access there? Just need to pull the thread and look into the files. Use it, change it. That would be it. How do we bypass an authentication? How do we skip username and password? The password is requested and exported true. So here we will find a screen what export should be true. So from the operating system, I can have prompt lines or command prompts and open that window. What if that gives us access to the private side of the app? That happens. Why is that? Because once you enter your username there, your password there, it will call that activity. As part of the source code, you have it up there. That's the name. The activity is welcome. That very activity, that export is true, I can call it from a command line, from a shell line. I launch it and I get that window, skipping everything before that. And everything before that, see, I just go into the command line through ADB. I use the activity manager. This is AM. So once I'm inside Android, I use the activity manager that we saw first, and I say start that app that is on. Is it a app? We got it on the manifest, and I want that app, the window that is called welcome. What's the result? In the end, I will have access to the private area. And the fact is that they got that export equals true. So export is true. I open the Android manifest, and the first thing you need to do, apart from identifying the launcher and the main activity, you cannot really see, but this is the app name. And I look for the word export. We see it's true, and we check the app name, and the activity is welcome. Good. So I can call it from command line. I launch the testing app, and inside of there I try out several passwords, but it will not work. What do? I found this, so I will bypass it from that prompt. Well, nothing. I log into the Android terminal. I start a shell, and with the package manager, I list all the packages. I don't know the name of the app, or let me know where it is, find it for me, find that app that has this in the name, shows to me the app name, and then I launch it. It says it's on data app, and that's the name. And once I have it, I launch the activity manager, and I say start the activity. Whose name and package is this one? Sorry, this package and this name are used. So when I launch welcome, there you see it?
You notice that when I launch it, it will access here, it will raise the activity, and without having to enter the username and the password, it will parse authentication of that app just by finding an activity with this portal. So once we find the launcher, we have to look up for the word exporter and then see what is the content provider, all the activities and all the services. We have to find out whether some of the services have been exported or not. So now, content provider leakage. Application A and B, they want to communicate. Each of them are in the respective sandbox, in the respective virtual machine. How do they share information? Right in the middle, let us put a content provider and fill it with content. And what happens if, look, I am inserting data. If that information, the content provider, as you can see here, within the Android manifest, if that provider has the property true, therefore it means that anyone could handle that. That is to say, that information could be accessed by anyone. So imagine an application with encrypted information of bank within the database. But then there comes a time that it has to communicate with application B. It takes information from the database, encrypts it, and includes it in the content provider. Automatically, if the content provider has the property true, the information that you had in your database, highly secured, encrypted, is no longer secure because content access is given to it. And here we have Smalley code, and it's very important to analyze Smalley code, and then we do that through grep -r content // and notice what we get every time. Once we analyze all the content providers, then you will see what we do, how we consult to that content provider. That address that you see there tells us just the address of the content provider, the URL of the content provider. So we start the app, we insert data, in this case CyberCamp. Yes, I am typing in CyberCampo 2016. I look for the property on exporter equals true. And now that I know that, I want to see whether I can get information out of that app. I go to Smalley code, and as I said before, I reversed this application before. Then I go to the source code, more specifically to the Smalley code, and I look for all the content providers, starting with the word content. Once I find content provider, I have it there. I want to check whether I have access to I can access information or not. Because I know that the property was true, the only thing that I have to do now is to ask a query to that sandbox where there's a thing an information exchange, and then to get that information. So this analyzing this Android manifest is basic, and then finding that information in the Smalley code is also basic. And then content query, the address, the URI, and then I ask it, consult that content provider, tell me whether there is some content in it, because there has been an exchange. If you have ever exchanged information with a content provider, the information continues to be there. Once you get there, you see information that you enter, amongst other, including the CyberCampo 2016 I've just entered, etc., etc. So this is for activities, information leakage, content in when these two sandboxes exchange information. And now let us move on to this section about insecure storage. How do you secure information? How do you store information in a secure manner? I told you that the best option is the web server. So in this case, what is the information that we have within the shared preferences? This is an app, version 1.53. Yes, this is the last one. This is an app for the GoFit sports centers or gyms. And for you to take a look at the timetables, you need to enter the username and the password. The first version did not require you to do so, but this one, it does. So notice what that information is being stored in a preference file, and it is storing it in plain text. Of course, that is not my key. As I say, password and username is stored in plain text. Then the center identifier, GF02, and CyberCampo. Once we access there, we have it. And then we can also look it up on XML files. If we use userinfo.xml, we may see very many surprising things, because often these passwords and users are used for this type of files. So this dash, I have included it for it not to be case sensitive. And now, one more example. That was example for storage under preference. Now I enter password and a username and I register. Then that information is stored in the database. However, the information is registered in this fashion. So if we are root users, we will have access to that database, and we will also have the access to obtain the DB point. And then if we get that point, we have access to this. Now let us see how you can access the database of a device right from the device. You don't need to bring the information. You have a light client from SQLite and you want to run the command right on the device. I run the app, I register, CyberCamp, oh again, CyberCampo. So registered, and the first thing that I want to view to get that information is first of all to know the name of the app and where it is, location of it. So we are going to find it, to search for it. I use the package manager, VM list package dash SQL. So we have the app there, Android pen testing, as it says on the screen. Then I go to the file, and only root users have access to it. And that's why I'm saying that when you do auditing, you have to be rooted. Then we use the database of this app. I use the SQLite client and then this database, and then I ask it to show me the tables on the database. We have the metadata table and others, but I want the metadata one, and I ask it to do many things for me, and then asterisk admin, and then see what information returns. Semicolon do. So we are accessing the database that is in plain text, and we are doing that from the device. This is a development failure. My app is stored in the internal memory. No one has access to that database points. Yes, access is open to that database. Imagine that we use a local exploit that raises privileges. If I run an exploit to become rooted, then from there I grab all the DB points and ask it to look for all the DB points and to transfer them for me. Then I have given access to the app to the internet. I download it and then I gain access to a great deal of information. And now let us move on to what we like apparently the most. Okay, here in the apps we can also inject code. How do you do that? Well, you do it in the same way, in the same manner. In this case, it is quite easy. So we will try to identify the queries within the source code. When it comes to identifying them, if I see shell asterisk adminware and parameter string 1 and mpass parameter string 2, what is the developer not doing rightly? Well, he's not controlling the entry parameters. At the level of the client, you want to control those parameters. Also at the level of the code in the server, in this case the app, and also at the level of the database, which is not often used, we should use pre-compiled queries. So therefore, it doesn't really matter if they inject like huge code. If you don't use a username or a password, the database will not allow you to use it. We have to introduce security in different layers, starting off by the customer that sees the interface, the server that checks the data, up until the database. We have to do that pre-compiled so that it can see that that password is not injecting any code. Doing that will prevent further problems. And how do we identify it? Once we have that, we can start playing. I start to inject code PPK or 1 equals 1, and then in the end we gain access. Is it running? Yes, it is. I run and start the app and I go to the login screen. First, quotes. Notice what happens. What do we do now? Well, cracked program, what do? We do a typical code injection. In the meantime, we look for the name of the package. We use the package manager for that, SQL. And as the app is being restarted, we log in. We do code injection. And then we bypass. We use the admin user, and then we enter any password or quotes 1 equals 1, end of quotes. And then it does the query for me. How bypass by injecting. So there are tools allowing me to explode SQL injection. What are we going to do now? I go to the smiley code, then I drag, and then I ask it to look for this keyword. Where? Then I will find the shell asterisk, etc. On the left, we have our root. Now I go to the code that I've reversed before, to the source code, and to the right root. The exact root is there up until we make it to this query. Here we gain access to the source code. We continue. Very important in the pen testing auditing process. Taking a look at login files is very important. So if debugging is active, it means that the developer forgot about that. Like here, there could be some information leakage through here. How do you do it? There is a script which I like very much, which is pitcat. So it gives colors to the log of the system. If I go and ask, give me the log of this app, and this is which is made in Python, shows me information for that app. This is the name of it, or for instance, a pen testing app. So this is a user that log on correctly once or twice, or by the time we authenticate ourselves, that will be marked in color in the system. If we did not restart the system, or if we use prior logs, old logging, we find that there has been a mistake with credit card 1111. What happens? In this case, by the time we will enter the valid one, we would also get that information leakage. Sometimes in log, we might find users and passwords that did not log on correctly, or that they logged in correctly. And from there, most of the times we can get the user. For instance, if they get the user right and the password wrongly, so we have information to start from. And when we are analyzing the network, what are we going to do? We are going to introduce a reverse proxy between my app and the server. And from there, I will start listening. As said before, for auditing, we can use a virtual device or a real one. If we want to use an emulator, we just launch it through HTTP proxy. We give the IP and the port where the proxy runs. If we want to use local proxy, if we want to use a real device, an actual one, I raise the proxy and I configure it through Proxy Droid application. That is to say that all the information coming out of my phone will go through that reverse proxy that I have in my machine, and for me to test it. If I want the communication to go through HTTPS, we will have to install security certificates in my phone. How do I do it? Well, within options of security, I can download the certificate that is available there. I'll give you the example that I like the most. You upload the emulator through the proxy. Reverse proxy is behind it, is running behind for the request. And thing is that the user and the password, or the so this tells me that this information is not encrypted. So what do I prefer? What do I like the most? I prefer to launch a TCP dump from my device. So for instance, I start an auditing, I start to play around with the app, I play Pokemon Go, but then I launch from the terminal a TCP dump. You have a version for Android, you download it, we upload it, and notice what we are doing. In the machine, I upload it with AV push, then I set action velocity, size of the package, and I tell it where to stop, 0 infinite, and the exit, w.apk. Then I go through all the options. I finish. I have my APK file, my device, and then I start to analyze it through Wireshark. So have here this filter, I can see where it's gone, where it hasn't gone, and I may use a monitoring tool and for instance say, okay, I will use network miner to see whether there are some active cookies, some credentials. This is just an example of how to do this. Mm. Okay. Okay, yes, I can stop it. So in the options offered by Google Bridge, you have the possibility to exchange files between my mobile device and the operating system. So that is to say my PC. In this case, I launch to a temporary file where I have a writing privilege, data local term, and the first thing that I have to do is to give it run running permission, and then I run the execution. I upload it with ADB push. I raise the command line, and once I raised it, I give permission. I gain access to the folder. I give access to it for execution. Well, this time I give all the permissions, and then I launch. I prepare and launch TCP dump. And Pokemon Go, and then I start playing with it. I have AirDroid, and so I can see what is happening on my mobile phone. I can see that on mobile phone, so I can run Pokemon Go whilst the packages are being read. I start my interaction, I enter user, password, all in all, I take a look at all the functionalities of the system. Here we have all this data. I authenticate. If it allows me to do it, it says failure GPS because I have not enabled it. So you can false all that. You can kind of forge your location. I enter the credential, my credentials. So it continues with the packages, capturing packages, and we will do exactly the same with the GoFit app. Same as before, I enter username, password, I log in, and now what I'm doing is capturing, gathering each and every one of the packages to store them for me, and then I bring them to my system, and that's it. That's the end. So here we have the different options, and I'm finishing now, and then we will have to be an ADB pull. ADB push, ADB pull doesn't say, and once I've done that, I will move on and analyze the APK file at the level of the connections, whether there are some credentials for some parameters, etc. You can do much more. You can check security failures in terms of local file inclusion, demo file inclusion. You can do very many of them. This is just an example of some of the most typical vulnerabilities out there. Tools. Tools that help us a lot. I recommend Mob SF. It is pre-installed in Android Lab. It is supported by iOS and Android. And the same as the online services that I showed you before, will allow me to upload the APK, and it will do coding and analysis at the level of the static code, dynamic code. For dynamic code, they facilitate a virtual machine for you, and they launch all the possible options. And then, if we have the time, we will run it. Then I launch server, Python manage.py run server, and now it is raising web in port 8000. I upload the app and it will automatically analyze it for me. It will generate a report with including the activities that have been exported, those that have not been exported. This is Java code, Smiley code. So therefore, it will make my job much easier. I may want to have information about whether some information has been leaked, whether there is any content provider. That will help me a lot. The only thing that I will have to do was to analyze the code and then to look up for some words. But if I have this information beforehand, I will use it. And before I finish, what summary can we do? Let us recap and see the things that are essential. Everything is based on this OWASP project. So gathering information is extremely important. In terms of manufacturer, we have taken a look at the various applications that we had from the same manufacturer, and then we will analyze those apps just in case whether there are any security failures in old libraries, and a library which is no longer there, but it's still signed and in operation. You can check that with the apps that have been updated in your operating system. You may uninstall them and then install the first version again. You will see whether it is still signed by the same certifying entity. That if the same user continues to sign it, it means that it has access to continues to have access to the server, and this is not the way it should be. Then installing the app, we play Pokemon, and then we start to test or to check whether what are the files that are generated when we install the app. We install the app, but not before we start playing it. We will get half an information. We have to enter the username, the password. We have to access all the options, all the possible options, so that the app generates all the functionalities and tells me about all the activities. Identifying the possible entry points. So where do I have a possible vector attack? So register, login. So any input will help me see whether there is an attack vector or not. And how do you do it? By browsing, navigating the application all through. And resources used, GPS requires an internet connection. Does it require any other type of specific permission? For instance, if it has Bluetooth, I know that I can look up keywords in Smiley or in other places that will help us fine tune our search and that will give us the information that we had before. Then, possible development frameworks. I'm sure that you are used to seeing web systems that have been created with WordPress, Joomla, with all of them with security failure. The same things happens here. What happens if you are using a framework for some of these applications and the framework has a security failure? What will happen will be that you will be using it in your auditing, such as could be Apache Cordova. You will be using it in your auditing to exploit the vulnerability and their failure. Try to find prior versions. So the APK Pure app is very good for that because it stores all the versions from the first one to the last one. In some apps have cleaned their servers and they do not offer the first one anymore. But if you look it up thoroughly on the internet, surely you will find it. It is important to download all the versions and then to compare the manifold Android of the last version with those of the first version. Let us take a look at the modification, the changes, and what is most important and the failure is in that they do not limit access, they do not disable access to old versions, to the prior versions. So type of app, we have to identify to see where my information is. Identify possible intentions that you call. I didn't mention, but within Android you have what is known as intentions. So when I am in the contact of my operating system, when I press call, automatically I have two apps. On the one hand, I have contacts, and on the other hand, I have the telephony manager. So they are referred to as intentions because you are calling an external service. And what do I have to do here? I have to identify right from the start and say, okay, I am on this app, and if I press this button, as it was the case with Pokemon Go, it is accessing to internet, to a web view, whatever website. It is launching a website. That means that there is an intention, and that intent could lead to an information leakage because I could ask it to inject code from the app. So intent within the app, once you are in the app, it's about how you are calling another resource in the system, whether it is through a phone call or, for instance, WhatsApp. When you look someone's profile, I don't know what are the options that you can do, edit a profile or whatever, that is opening it. When you change your profile photo, it is accessing your gallery. That's an intent. It is calling the OS, so that we don't get lost in the process. We have the checklist of OWASP, and this will help us go step by step, do all these analysis so that we do not miss anything out. So installing the app, reviewing permissions, taking a look at manufacturers, at attack vectors in terms of the inputs. We have gathered lots of information. That information will guide us in our static analysis. By the time I will do reversing, I have lots of code in my mind as to where I can find information. Okay, we review it. So after using the APK tool, and then Android manifest, we detect the launcher. So we have to see whether the application can be debugged or not, whether there are activities or not. Are the content providers with the property exported equals true? This is what is most important, because that this is where information leakage would come from, and that will be shown on the customer reports, so that we tell our customer this is not secure, you have to change this and this and that. If you check whether there is an exported equal true property, this tells me whether there is a failure or not. Obtaining the name and of the package and the launcher. We did that several times through the process. Then I take a look at the main activity, and then within the Java code, I analyze the package hierarchy. I go to the activity, and then I get the starting source code. Then identifying services that may run parallel within that main activity, within that main or first window or source code. That's where I will be raising services. Imagine that I get an APK from meta exploit and an APK which is valid. When we are binding that code, when we bind that code, automatically what we are doing in the main activity, what all the apps on the internet do is the following. In the main activity, they launch a thread in the main activity, and they say launch this service in secondary plane. When we analyze that launcher, that first screen, we will see whether there is running service or not. There is another way to do it. You can do it in Smiley code and then meta exploit. Then you just paste it on the call. You paste the com meta exploit in the file of the application. You compile it again, and you get exactly to the same place. So the main activity will always be compiled in .zip. In the first screen, you will find code execution with a thread to a service that will be running in the secondary plane. And the same goes for malicious app. That's the way you can identify it. So what does the app does for me, and what are the permissions? There is a framework which is known Android World. And within this framework, we have the option to say, I want to find the source code where these permissions are used. What information will I get from there? I can analyze the code and then to see that if this permission is just here at this point in time in this part of the game, is it valid or not? Shall I allow it or not? I don't know whether it has happened to you, whether you have touched code or not. For instance, if you get an app of any app, you reverse it, and then automatically you modified some of the source code, and then you disable some permission, then you compile the app, you download it, and then you make sure that that app will not have access to the GPS. Depending on how the source code is made, then the app will fail or not. If you run it in secondary plane, that error is controlled in Java with any kind of code. So, verification of API and possible metadata. So, it didn't mention that depending on the software version and the functionalities that we use, we will have a bigger or smaller API. There are certain functionalities of several API and Android and SDK app that are vulnerable. So for instance, if I manage to reverse the source code, and if in Android manifest, I tamper with the minimum API and I run the program again automatically, the function that is used in API 23 now is run on API 16, therefore making the program vulnerable. We have to take this into account when it comes to static analysis. Hard-coded information. What can we find here? API keys, secret keys, passwords. I showed you examples of that. How are data stored? Well, several ways to do it. You can do it on a local database, shared preference, internal memory. Do not use the external memory of the SD card to install apps on it. Why not? Well, because it has access to each and every one of the apps and then may lead to information leakage. Other possible data, possible SQL injections just by searching or making a search on Smiley. And why is it? Well, because some developments are not secure. Identification of connection sockets in the source code. If you reversed the APK generated by Metaexploit with malicious ware or with malware, it is very easy to find the communication software, the IP it connects to. You can find that through the open source. You just do a search on the Smiley code, then you read the code in Java, and once you have identified the launcher, that main activity is detected, then you go to the open source, and then the main window, main activity, it's very easy to see what is being run. All in all, it's Java code. You may find it, but the main activity, the main window, you will always find. Then looking for chains, code injection or content providers. And last, in dynamic analysis, using TCP dump if you don't want to filter with any reverse proxy. You save TCP done and you start sniffing traffic in the machine, monitoring all the logs of system logs. I recommend Pitcat. This is the Python script that colors the logs as well as the warning messages, the information messages, debugging messages. Each and every one are given a color code for the application you select. And it is very helpful to see the log of an app on the OS because it will filter it for you. You don't have to say download all the log of the system so that you have to look for the application and for the information that has been given in terms of the log. This is direct filter. There's a direct filter and then it colors information for warning, debugging and error messages. Another possible analysis, we have another app which is Droidbox. I asked it to identify different things for me. For instance, the hashes. This is very good for malware. It analyzes SMS information and calls. It looks into the source code. That information is stored in the device after interacting with the app. As I said before, not until I switch off the device. I may have some content providers with information, and then I may go and say, well, I have entered. No, I'm not showing you the app again. What happens? That information continues to be in the content provider. So they haven't seen the password that you entered, but that information continues to be there in the content provider. And all that is included in the checklist of OWASP. And well, this is everything that I wanted to share with you. I hope that you have found it of use. I know that it is lots of information, and I would like to thank the organizers again for having invited me, and I would like to thank you very much for your attention at 4 o'clock in the afternoon, and I hope that you like it, and I will be around. See you later.